In this video, I'll be breaking down and testing all 3 CNC inlay techniques, from easy all the way up to expert. I'll be showing you how each one works, what bits I used, how to program them, and how they compare in detail, cleanup, and time. So by the end of this video, you know exactly which inlay method to pick for your next project. Let's get right into it. So the first inlay technique we're going to be covering is the straight flute inlay. Now, what is the straight flute inlay? Well, it's simply you cut a straight slot, you put another piece of material, and it goes straight into it, hence the straight flute inlay. Now, this inlay is typically done with just normal finisher bits or roughers, etc., where you're just taking this bit, pocketing out something, and once again, putting the other piece, the mirror image, right into it. These are the simplest and the fastest to do. But why would somebody want to use a straight flute inlay? Well, why they would want to use it is to do something like this, right? Something that is not complicated. You can just cut out a letter, put it in there, and whenever I did this on a previous video, which if I went in depth on straight flute inlays, it only took about 20 minutes for the whole entire process. So it's very quick, very efficient, and really, really simple and straightforward to understand. But the limitations are that you can't get really sharp, detailed corners and stuff like that because you can only go by the diameter of the bit, right? And so if the diameter of the bit is a 1/4 inch, your corners can only be that 1/4 inch diameter, that 1/8 inch radius, that is the bit. For this inlay today, because it is a little bit more intricate, I'm gonna be putting an 1/8 inch roughing bit in there. You can use an 1/8 inch finisher, that's fine. And this is gonna be about the tightest radius corners that we're gonna be able to achieve with a straight flute inlay. So we have this beautiful ingrained walnut from our inlay kit builder on CIC Workshop. This is a damaged one that we couldn't send out, so you know me, I gotta use it. And for the base, we're gonna be using spalted sycamore, which is going to be a perfect contrast for the design that we're doing today. Now, whenever you do straight flute inlays, it's very important to do the male plug first, then you do the female. I'll explain why when we get to that point, but just know we're gonna be cutting out the male first, then the female. So let's get this thing held down and then I'll show you the programming. This is the image we'll be inlaying today, and this is about the most detail you can get from a straight flute inlay. So we'll be selecting the inlay toolpath, doing a male insert, but before I do that, I actually am going to flip this design to the right. Now you do not have to do it, but I'm creating that mirrored image because this edge right here is the side that's going to go in that pocket, and so I want it to be clean because I'm going to add tabs to this. And so we'll actually be cutting out this in order to make this right here. You do not have to do it, but this is just a pro tip. And because it's so detailed, we'll be cutting everything out with an 1/8 inch rougher, and I'm gonna push the limits and I'm gonna go 100 inches a minute on it, and my plunge rate is always half of my feed rate. Then I'm gonna come by, add a couple tabs in here just to make sure it doesn't pop out of that. So the reason we want to use the inlay toolpath instead of the normal profile toolpath is that inlay toolpath accounts for the diameter of the bit on both the male and the female part that we are about to do. So it's gonna round off these corners to make the bit easier to pocket and make it easier to cut. So whenever you're doing this, make sure that whatever you use for the male inlay, like this 1/8 inch bit, you use for the female inlay as well. All right, so we got it all held down, programmed up. Now before I cut this, I wanna make a few notes that on a straight flute inlay, you know, you always want your material to be level, but it matters a lot less on a straight flute inlay if there's a slight warp in any one spot, because it's still going to fit in that cutting board just fine. Now, with this particular one, I do have it at 0.6 inches thick, but if you are only like at 3/8 thick or you have a 1 inch thick piece material, it's gonna be just fine. It's gonna inlay just fine. So don't worry if yours is a little bit thicker or a little bit thinner. So we have our 1/8 inch upcut rougher in there, which is the baby boy. I'll get to click and go, and this thing is gonna cut it out in 4 passes. It's really cool. Let's go. So I have this 1/8 inch rougher actually going at 100 inches a minute right now, and you can hear that, right? Cutting it like butter. And you can use an upcut on in grain, because upcut or downcut really doesn't matter because of the grain direction. And so this bit is cutting all the way through it. That way we can see the exact inlay that we're gonna put in that female. So it's really cool. I just want you guys to see real time what this bit's doing and what it sounds like. So it got cut out, it's really good, and I did cut all the way through this, and that's pretty typical with these straight flute inlays. Now, I did tab it up, but there is an argument to be made, because on the video where I did this D, I used a downcut bit to cut out the D, and all of the wood chips kind of held it in place so it didn't move around. I think the same thing would have happened if I did not use tabs. So there is something to be said about that, but just real quick, to break those tabs, I just kind of pop out everything. Voila, right? That's it. So now all we have to do is pocket out that female. So I'm gonna get this thing held down, and then we'll program that and start getting it cut out. To do the female, we'll get this male flipped version out of the way, get the regular one in there, and then we come back, go to that inlay toolpath, select the female pocket, and we'll be using that baby boy again. Now you can put a 1/4 inch bit in here and take out more material, but this is just going to be just fine. Now I'll be cutting a 1/4 inch deep. I'm actually going to do it in one pass, and we'll probably go around 80 inches a minute. Now the most important thing on the female is that we do an overcut distance or an allowance, and that's just going to make this a little bit bigger so the other one fits. Now, I'm going to do it at 0.002. Sometimes you can get away with 0.001, or sometimes you have to go to all the way to 0.01. It just depends, but for video's sake, I'm going to try a 0.002 overcut distance with that on this right here. We hit calculate, and as you can see, it's just going to pocket everything out like that. And that's it, super simple. So as I set the X, Y, and Z 0, it is important to note that the Z height, if it's off just a little bit on straight flute inlays, it's okay, right? Because either this deer is gonna go a little bit further into it or a little less out of it, right? Not a big deal. And so that's why I think these straight flute inlays are really beginner friendly, because there's so much room for error, right? You don't have to be just perfect when you're doing these. So I got the golden baby boy rougher in there again, and we're gonna be running that at 80 inches a minute at a 1/4 inch pass depth. 1/4 inch deep is plenty fine for male inlays. So let's get this thing fired up. There.
Oh yeah, I love that one.
And we are using the alt mill throughout this whole entire video. So if you're interested in that, check the link in the description. It does help out the channel. So we got it pocketed out. It's looking fantastic. But here's the moment of truth. Does this deer fit? And remember, this is why we do the male first and the female second. Because if this thing does not fit, then guess what? All I have to do is reprogram it and make the pocket tolerance just a little bit bigger. So moment of truth. Oh yeah, baby. Snug. And I'm not even gonna try to press it down too hard, but it fits. It's like the most satisfying fit, I will say that. Little eyeball, boop. All right, so to press this down, we're gonna be using our inlay press. This is something I designed. I made a full video over how I designed it. All right, got it clamped down. Everything is good to go. We will come back tomorrow and finish it all out. there, and then it's going to do. All in all, it came out great. I'm really happy with it. Let's take the difficulty up a notch with the next inlay method. That brings us to our next inlay method that we're gonna test today, which is the V-Carve inlay method. And how this method works, it uses V-bits instead of straight flute bits. And what that allows you to do is to achieve these really tight corners. And so the male is gonna go into the female just like this. There's some certain parameters that you need to set. There's a little glue gap on the bottom. I've made a full video over it, so I'm not gonna go crazy into depth on the technical side, but just know you can start achieving really tight corners and really nice images. So whether you wanna do some kind of scenes or nice text and stuff like that, that is not possible with that straight flute, the V-Carve method is going to be the method for you. So today, we're gonna be taking a walnut male plug and a maple base, and we're gonna be doing an image with some really fine text that is really going to show how detailed a V-Carve method can do. So we have our base piece held down, which means we're gonna do our female part first. We're just gonna do a 1/4" pocket depth. And I'm gonna be using my two favorite bits to do inlays with. One is a 30° V-bit, and the other is a 3/16 upcut. I like the 3/16 because it gives me that strength of a 1/4" bit, but like the detail work of that 1/8" bit. So we're gonna put the 3/16 upcut in there first, do a lot of the clearing out, and then we'll come back with that 30° V-bit to do all that fine detail work to give us those tight corners. So let's get to programming it, and then come back and start running the CNC. We'll be doing a V-Carve inlay today on this John Wayne with this quote, and we'll be following this V-Carve inlay method that I've been using and showing in multiple different videos. So we'll be doing the pocket. Now I can use the V-Carve inlay toolpath, but it's a little bit more confusing to show on a YouTube video, and this other way is going to work just fine. So we select V-Carve. We're going to be using that 30° V-bit and that 3/16 upcut with a flat depth of a 1/4", so our 1/4" pocket depth. So we're going to select the vectors. Here are my feeds and speeds, 100 inches a minute for that 3/16 upcut. Pretty aggressive, but still okay. And then for that V-bit, you can go 60, you can go 90, really doesn't matter too much there. And hit calculate. So that 3/16 upcut is coming around first, clearing everything out, followed up by that 30° V-bit, and I highlighted that in black so you can see where it's at.
Yeah, go for it.
All right, clear out bit just did its job. Now it's time for that 30° V-bit to get in there and put in all those fine details. So another difference with V-Carve inlays is there is going to be a little bit of cleanup work, so you always need to have some kind of a stainless steel brush, brass brush laying around. That way you can go in there and get out all of those fuzzies. So once I get this cleaned up, we'll take it off, put the male plug on, and get to cutting that one out. So we got our male walnut piece held down. Same concept, 3/16 clear out first, followed up by that 30° V-bit. And one more note I want to make about this V-bit, it's a solid carbide 3-flute V-bit, and so it can go that 1/4" full depth, and the tip's not going to break, and it can really move. So that's just an important side note with the V-bit that I'm using and how I'm using it. Let's go show you how I program this up and get to running it. To do the male version, we'll take the female part right here, and we're actually going to mirror it to the right because you always need to do the inverse of it. So we're going to take those vectors, do an outwards offset of a 1/2 inch. You can do 3/8, that's fine. Deselect that outside and delete all those little ones that it popped up with. Boom. And now we're ready to do the male part, and we'll be following these guidelines right here. And what they tell us to do is we're going to select all the vectors, do that same V-Carve engraving toolpath, and we're going to have a 0.23 plug depth, which means we need a 0.23 start depth, and we want a 0.1 surface gap, so we're going to put a 0.1 flat depth. Just trust me, it makes everything you're seeing here if you just do that. Once we have that, same 30-degree V-bit, same 3/16 upcut, hit calculate, then we will run that 3/16 bit first like that, followed up by the 30-degree V-bit, and it is going to do the exact inverse of what you just saw. Now, I didn't go in depth on this because I have a full video dedicated to the V-Carve inlay method. If you have not seen it, do check it out. So our clear out bit did its job, and I just want to make this one note that whenever I'm touching off with that V-bit, just know that that glue gap is really like a tolerance. So where that straight flute, it doesn't really matter if your Z height is off or not. With a V-Carve inlay, you do need to be pretty exact on where you're touching off at. So try to touch off in the same spot and always make sure your material's flat. That's why I put those extra screws in, because you only have 0.02 inches of tolerance if you're following the settings that I used. And so you just want to make sure that you don't screw up that Z height.
And yes.
This thing turned out amazing. And that V-Carve method, that 30-degree V-bit, these points on these letters are so sharp, it is nuts. So I think it turned out really good with the kind of look, right? The black silhouette, the maple being that white background, really made everything stand out. This to me it looks more complicated than it actually is using that V-Carve method. You saw how I did it. Everything went together good, and all in all, I'm pretty dang happy with the results. Now, with all that being said, this is nice, but let's crank it up a notch to the most difficult inlay method out there, one I have never done before, and only the masters do it. And that is the tapered ball nose inlay method. So what makes a tapered ball nose inlay method different than the V-bit? Well, because of the taper, you're getting a lot tighter angle. And so with a V-bit, you get an angle kind of like this. With that tapered ball nose, it almost looks vertical. And what that does is gives you technically a lot tighter inlay, right? A lot better bond and glue joint and a lot deeper inlay whenever you do really fine detail stuff. The problem is it's really freaking hard, like really hard. I took a whole entire course on how to do tapered ball nose inlays before this video, just so I can show you how it's done. So I went to Bro and Wood and I was like, hey bro, show me how to do this. You're extremely good at inlays. And he showed me how to do it. So here is a quick difference between a tapered ball nose and a 30-degree V-bit. They both can relatively achieve the same thing, But if you want super fine details with a really deep method, you're going to have to use the tapered ball nose. The problem is finding the settings, right? These settings work with a 30, 60, or 90 degree V-bit, hands down, works every time. With the tapered ball nose, you can throw all those settings out of the window and you have to find it for your specific bit, from your specific manufacturer, for your specific radius on your tip. And it gets pretty complicated. And just to figure out the parameters that I'm about to show you, I had to test for about 3 hours to figure out which method was the best method. And then I tested right here to see if it actually worked and ended up being good. So there's a lot of nuances that make this a pain in the butt way of doing things. And I put this level of CNC inlay at the expert level, not at the beginner level by any stretch. So stay tuned and watch as I struggle trying to do this level of inlay. All right, we got our material held down and the 2 bits we're gonna be using. I'm gonna be using an 1/8 inch bit for the clear out. This is gonna be an 1/8 inch upcut. And then I'm using a 64th radius, 6.2 degree tapered ball nose for the detail work. So let's get to cutting this and then we'll show you how to program. And if you want any of these bits that we've used in today's video, whether it's a tapered ball nose, the upcut, the 30 degree V-bit, and if you want any of the materials that we use, whether it's the walnut base, the spalted sycamore, any of the tops, check those out. We do have a custom ingrain kit builder on CSE Workshop as well. Now, let's get to programming. This is the digital file we will be inlaying today. I wish I could say I drew this, but I just hopped on over to Brownwood and bought this digital file because he has done all the work for you, rounded over all these corners that a tapered ball nose inlay has to have. As for the programming side, just a V-Carve, and I'm going with a flat depth of 1/4 inch, just like a V-bit inlay. And then I have my 6.2 degree 1/4 inch tapered ball nose. And here are the settings for that. Of course, I have that 12.4 degrees because 6.2 times 2 is 12.4 degrees, 3 flutes, and here's all my settings. And I'm using that 1/8 inch tapered ball nose. And whenever we carve this, the 1/8 inch bit does the work there, and that tapered ball nose is going to come back by and do all of that work right there on the female part. All right, the female walnut piece just got cut out. The design looks absolutely crazy. The tapered ball nose went in there and did a really good cleanup job because of that upcut-ness of it, right? So I'm gonna get that male put on there, get it cut out, the same exact scenario, use an 1/8 inch for the clean out, and then this 1/64th tapered ball nose is gonna go in there and do a lot of the work. This part right here took 2 hours to cut out just on the female version. So these tapered ball nose inlays are not only more complicated, they're also taking longer on the CNC. But dang, they look cool. So let's get that male part on there and get to cutting. Now for the male plug, it's the same as the V-Carve inlay. We will flip to the right and then do an offset. And since I'm really tight on this, I'm going to do a 3/8 offset just like so. And now we have our male plug, which is the inverse of that female right there. Now for the toolpath, we are using a V-Carve engraving toolpath again, and the start depth is 0.09 inches and the flat depth is 0.24 inches. And I do want to make a note that this is for my particular bit on this particular day when I was using it. So do not think you can plug in these settings if you have a different tapered ball nose bit. It will not work. Now, if you do want me to go in depth on how to do this, I can make a full video over tapered ball nose inlays and tell you exactly how to do all the stuff yourself. But this is just to show you how hard it is or how easy it is. So the 1/8 inch bit is going to come and clear everything out right there, followed up by that 1/64th radius tapered ball nose, which is a 30 seconds diameter tapered ball nose. So if you'd like a full video over this, let me know. Do not try to copy my settings if you do not have our 1/64th tapered ball nose bit from CIC Workshop. All right, just got the male cut out as well. This one took about an hour and a half. So in total, we're about 3.5 hours in on the project. And this thing looks just as insane as this female one. But let's see, I'm just gonna do a dry fit and give you my initial reactions here. Oh, it fits. Woo! That's the main thing, right? It has to fit. But I will say, it feels like it's just a lot tighter. I'm not gonna press it down too much. Yeah, because look at that, like I hope all my parameters are good, but it just seems like it's very tight, and I think that's that really steep angle where this actually does need a ton of pressure whenever we glue it. All right, just pulled the tapered ball nose off of the press. It's been sitting for 2 days now, and my confidence level is probably a 7 out of 10. It's not perfectly even across this front, so we'll see how it works out. This thing is insane. First couple thoughts, color contrast works really well with that walnut and maple. It actually came out better than I thought. I thought, you know, with all those clamping pressures and stuff like that, I wasn't gonna get a super tight, beautiful inlay. I do think if I had just a little bit extra pressure, I could have got these words right here just a little bit better. But all in all, this thing turned out fantastic. Now, with that being said, this is a 1/64th radius tapered ball nose that did it. And so I've said this a couple times throughout here, but if you notice, any of these points are slightly rounded because of this tapered ball nose. And so that's the big thing when you're looking at a tapered ball nose versus that V-Carve, is the V-Carve is going to be able to get super tight corners. The tapered ball nose will get a much deeper inlay, but it also has to have slightly rounded corners, which is a whole nother topic and a whole nother programming thing. That is everything you need to know about all 3 types of inlay methods. We tested each one. I gave you tips and tricks. I hope you learned a lot from this video. Don't forget to like and subscribe. And as always, guys, remember, if you ain't cutting it close, you ain't cutting it right.